Welcome to Lesson 2, Calculating Concentration in Industry. So when we are working in the lab, we will be using a different method to calculate concentration. However, products that we buy on the shelves, such as rubbing alcohol, cleaning products, um, cleaning supplies, medical grade antiseptics, they all have different methods of showing you the concentration. So we're going to take a look at those today, and then we will take a look further in the unit about molar concentration, which is used in the lab. So going forward, let's first of all do a review of yesterday's lesson. Yesterday we talked about dissolving, dissociation, and ionization. Today, let's compare what we know. So I'm going to give you a couple minutes to work on this, pause the video, and then when you are ready, you can compare your answers. Okay, so let's go through this. It says calcium carbonate is added to a beaker of water. From here, it asks us, does it dissociate? And how do you know? So in order for it to dissociate, it needs to separate into ions. And for that to happen, it needs a high solubility. So you're going to go into page 6 of your data booklet and use your solubility chart. First thing you do is write a chemical formula for the compound. You're going to see what ions form this compound. There's a calcium 2 plus and a carbonate 2 minus ion that form this compound together. From here, you're going to locate the carbonate or the negatively charged ion on your chart. Okay, so going through this with my mouse, there is carbonate. We are going to read down. It says group 1 ions and ammonium would lead to a very soluble compound. Okay, but calcium does not fit in that group, so we see if it fits in this group. It says most other ions, when they're reacted with carbonate, will be slightly soluble. So based on this information, we, dis we discover that calcium carbonate has low solubility. And because it has low solubility, it will not dissociate. Okay, so does not dissociate because low solubility. All right, let's take a look at the next question. Will the solution conduct electricity? Okay, so think to yourself, ions need to be formed for something to conduct electricity. And for it to form ions, you need to have a high solubility in water. So based on that information, I'm going to say no, does not conduct electricity. Okay, and the reason being because it is a non-electrolyte. Does not form ions. The final question asks us what entities will be found in the beaker. Entities basically means what substances, what ions, what molecules will be found in this beaker. So in this beaker, we're basically going to have water, H2O, floating around, and within it, we're going to have compounds. We're going to have calcium carbonate kind of just floating around. They will not separate into ions. Okay? So if I were to answer this, I would say water plus calcium. That's not how you spell calcium. Calcium carbonates. Perfect. Like mentioned, our lesson today is going to cover the following things. So we're going to identify different ways to measure concentration in everyday lives. calculate percent by volume, percent by weight volume, ppm, and ppb. The first one we're going to start off with is percent by volume. This is usually how we report concentration on things like rubbing alcohol. Okay, so the formula for percent by volume is listed right here. Volume of the solute over the volume of the solution multiplied by 100, because we're going to get a percent. So this is a ratio of the solute to the total volume of solution. So I'll get into details of what that actually means. Let's do an example. Example 1 says if you took 10 milliliters of pure ethanol and added it to 90 milliliters of water, what would the concentration be? So we're using our formula, percent volume to volume. I know it's volume to volume because I am working with volumes here. Milliliters is a way to measure volume. Is equal to V solute over V solution times by 100. Now you need to decide which one is our V solute and which one is our V solution. V solute is going to be the smaller amount. And I remember this because the word solute has less letters, therefore it's going to be the smaller amount. So I have 10 milliliters of solute. Okay, so going forward, let's draw a picture of basically what is happening. In a beaker, let's say, I add 10 milliliters of ethanol. To that, I add, from here to here, there's 90 milliliters of water. Okay, this one is going to be my solute because smaller amount. All right, from there, we need to do our V solution. Now, like I said, V solution is the total amount of solution in the container. So here, we actually have a total amount of solution of 100 milliliters. And I get that by adding the two solutions together. 90 milliliters plus 10 milliliters times by 100, which gives me 10 over 100 times by 100. My final solution. Now, there's a specific way when you're reporting an answer. We're going to say that it's 10%, and then you're going to state the type of formula we used. It was percent by volume of volume. Percent volume of volume in a total amount of solution of 100 milliliters. I want us to get into good practice of this. I will be lenient in the beginning, but this gives me a lot of information of what it's saying. 10 milliliters of volume to volume ratio in a total amount of solution of 100 milliliters. Let's take a look at working this formula backwards. Mosquito repellent is 45% DEET by volume. Okay, so it's telling us it's 45% DEET by volume. So we're going to use the volume to volume formula. DEET is that chemical that prevents mosquitoes from biting you. They don't like it. If the bottle of repellent is 75 milliliters total, what is the volume of DEET in the bottle? DEET is going to be our solute, okay? Because we're looking at this is the total, so it's going to be our solution. Let's use our formula. V percent volume to volume. Okay, so the formula, percent volume to volume, is V solute, so this is the smaller amount, over V solution, which is the total amount, multiplied multiplied by 100. Let's go ahead and plug these values in now. The percentage is 45. Okay, this represents the percent. So 45% is equal to V solute over V solution. This number here is saying total volume, so this is going to be my V solution. So let's plug that in. V solute over 75 milliliters times by 100. Let's go ahead and isolate for V solute now. I'm going to divide both sides by 100. 100 and 100 cancel out. This gives me 0.45 is equal to V solute over 75 milliliters. We're going to go ahead and multiply 75 milliliters on both sides. Okay, because whatever we do to one side, we must do to the other. Cancel, cancel. V solute is equal to 75 milliliters multiplied by 0.45, which gives me 34 milliliters. Okay, 34 milliliters of DEET. DEET is our solute. Okay, this is what we are looking for. We round to two significant digits because this number is two significant digits and this number is two significant digits, so we will round to two significant digits. Okay, let's do another example. We're going to take a look at percent weight to weight. Basically, this is the same as the percent by volume, but instead of using volumes, we are now using weight. So instead of volume, we are now going to have, this is the ratio of the solute, which is a mass, to the total mass. To the total mass of the solution. Okay, a solution basically doesn't need to be a liquid. We can call solvents, sometimes metals in jewelry, one of the metals will be considered the solvent and one of them will be considered the solute, depending on which one we have more of. Okay, so this is the same as the other formula, but instead of using volumes, we will be using mass. So in this example, we have a necklace that contains 30 grams of gold, 0.21 grams of nickel, and lastly, 0.59 grams of iron. Okay, most jewelry is made from a combination of different metals. Depending on how much gold, the percentage of gold that you have in jewelry, that will affect the carats of gold, and that will affect the price. The more gold, the more carats, the more expensive your jewelry is going to be. So in this necklace, it's asking us to determine the percent by weight of gold in the necklace. So gold is going to be considered our solute. So this will be my weight solute. Okay, so the formula, percent weight is equal to the weight of the solute, or the mass, over the weight of the solution, times by 100. Notice how the formula is exactly the same. We are just using measurements of mass versus measurements of volume. Okay, so we're going to plug that in. 0.3. 0.30 grams of gold. And then on the bottom, we need to total it up again. So W solution is equal to 0.3 plus 0.21 plus 0.59 grams. When we add that all up, that should give me 1.10 grams. When we plug this in, this number will then go here. 1.10 grams, oh, and multiplied by 100 because it'll give us a percent. So times by 100. This will then give me a percentage of 27% weight by weight to a total mass of 1.10 grams. Okay, so it's saying there's 27% gold at a weight by weight ratio in a total piece of jewelry that weighs 1.1 grams. Let's look at the percentage of nickel in this necklace. Okay, same necklace, but now we want to look at the percentage of nickel. So same formula, percent weight by weight is equal to the weight of the solute over the weight of the solution, which is the total mass, times by 100. The weight of nickel is 0.21 grams over 1.1 gram times by 100, which gives me a percentage of 19% weight by percent with a total piece of jewelry that weighs 1.10 grams. Okay, now we're going to combine the two. So let's say we're taking a solid, a mass, and we are dissolving it into a liquid. Okay, so the percent weight per volume formula is known as the weight per volume. The formula looks like this. The units are very specific for this one. Mass must be measured in grams, and your solution or your volume must be measured in liters. So you need to be actively checking to make sure that you have these units when you are using the formula. Okay, so the ratio of weight or mass of a solute measured in grams to the volume in liters of a solution. Let's go ahead and do an example. All right, we have an example saying a salt solution that contains 4.5 grams of NaCl is dissolved in 135 milliliters of water. We need to determine the percent by weight. Hold on, I gotta make an adjustment here. This is actually milliliters, and this is volume in milliliters, okay? So fix that up. Okay, so let's go ahead and use the formula. Percent weight by volume is equal to mass of solute in grams over volume in liters. All right, and then multiply by 100. Okay, this is pretty simple. All you need to do is make sure that your units are in the correct order. Sorry, this should say milliliter. So we check to see that our mass is in grams. Perfect. We can plug that in right away. We check to see that our volume is in milliliters. Perfect. We can plug that in right away. Okay, and then multiply by 100. This is a very simple calculation to put into your calculator, and we're going to get 3.3% weight per volume to 135 milliliters. Now, this percent weight by volume is very specific. When we write that, we know that the units were grams and milliliters. That's why the units matter, okay? If you use other units such as liters or milligrams, it's going to give you the wrong answer. So you need to ensure that you're using the correct units when you're doing these formulas. Okay, let's move forward. Okay, we're going to do a using that same information, we can set up a ratio to find out how much salt, how many grams of salt we will have at different volumes. So basically, this becomes a ratio. You have 4.5 grams over 135 milliliters, okay? That is a ratio. We can represent it as that, or we can represent it as 135 milliliters over 4.5 grams. There is our second ratio. Now it's asking us how much salt will be dissolved in 270 milliliters of water. So what we're going to do is start with our known 270 milliliters of water, and then we're going to do unit analysis using one of these ratios. So I am going to select the ratio A because it will allow me to cancel out the milliliters. It will allow me to cancel out the milliliters and keep the grams. So in my calculator, I will be plugging in 270 multiplied by 4.5 divided by 135, and this will give me an answer of 9 grams, which makes sense because 135 doubled is approximately 27. We round that to 2 significant digits. All right, let's do that again. It's asking how much water will be needed if there is 27 grams of NaCl. So same thing, we have our two ratios, 4.5 grams over 135 milliliters, A, or we have 135 milliliters over 4.5 grams. We're going to start off with what was given to us in the problem, 27 grams. Now, select a ratio to complete unit analysis. This time, I'm going to choose B. So I put 135 milliliters over 4.5. Grams cancels out and I'm left with units of milliliters. Again, in your calculator, you are going 27 times by 135 divided by 4.5. You're going to plug that in and then round it to the appropriate sigdigs. 35 gives me 810 milliliters. Okay? If we were going to sigdigs, this would be 8.1 times 10 to the 1, 2 milliliters. There you go. All right, the last way that we can measure concentration in industry is parts per million, which is ppm, and parts per billion, which is ppb. The formula is the same. Mass of solute over V solution. However, it's the units that makes it parts per million or parts per billion. When you are working with parts per million, your mass needs to be measured in milligrams, and your volume will be measured in liters. So the units that you will get, the units of ppm is milligrams per liter. I want you to get comfortable with this. Sometimes they will say you have 880 parts per million of mercury in a solution. This is the same thing as saying you have 80 milligrams per liter. Sometimes you will need to convert the units so that it makes sense when you are doing your problems and isolating for variables. Okay, parts per billion, your mass is going to be measured in micrograms and your volume is going to be in liters. So your units are micrograms per liter. So if I say I have a carbon dioxide concentration in the river of 78 parts per billion, That is the same thing as saying I have 78 micrograms per liter. Again, that unit conversion is going to be helpful for you when you are doing problems and manipulating the variables. Let's go ahead and do an example. A 250 milliliter sample from a bottle of water contains 2.2 milligrams of oxygen. Calculate the concentration of oxygen in parts per million. Perfect. ppm is equal to mass measured in milligrams over volume measured in liters. Our mass is already in milligrams, so we can go ahead and plug that directly into the formula. Divide that by our volume. Our volume needs to be converted into liters. You will need to divide by 1,000. That is the same thing as moving your decimal 3 times over. So in liters, it'll be 0.25 liters. Once you divide that out, you get an answer of 8.8 milligrams per liter, or 8.8 parts per million. Both of these tell me the same information. You are going to try the next example on your own, which says an air sample with a mass of 0.5 liters contains 3.2 milligrams of formaldehyde. What is the concentration of formaldehyde in ppm? I want you to pause, and when you are done, you can come and grab your answer. The answer for this problem is 5.4 parts per million.